What we're going to work through here are some examples of trigonometry where you might apply the circular definitions of sine, cosine, and tangent. Sometimes they're called the x, y, r definitions. So all the problems here assume that you know those definitions and can work with them. If you don't, you might want to go somewhere else to get that background information first. Our first example, the point P with coordinates negative 15, 8 is on the terminal ray of some angle in standard position. What are the values of the trig functions of this angle? So to calculate the values of the trig functions, we really only need three values. We need the value of the x-coordinate, we need the value of the y-coordinate, and we need the value of the radius. What radius, you might ask? Well, the radius of the circle. So the point negative 15, 8 is going to be a second quadrant point. So we'll have an initial ray and a terminal ray going through that point. Now, I don't know what rotation, what theta this is. Maybe it's a positive angle, a negative angle. I don't really know. But I can draw a circle through that point P, centered at the origin, that would give me a radius through the terminal ray. So I'm going to need to calculate that. And I can calculate that by using the standard equation of a circle centered at the origin, x squared plus y squared equals r squared. So that would be negative 15 squared plus 64 equals r squared. So that r equals, now I believe that's going to be 225 plus 64. I go through that, and we're going to have 289, take the square root. So r is going to be 17. Now that I have r is 17, I have everything I need to calculate sine, cosine, tangent, as well as the reciprocal functions. So I'll go ahead and do that. Sine of theta, defined as y over r, would be 8/17. Cosine of theta, defined as x over r, will be negative 15/17. And tangent of theta, defined as y over x, would be negative 8/15. Now, whether you put the negative out in front, or the negative with the 8, or the negative with the 15, it doesn't really matter, although it would be unusual to leave the negative in the denominator. From here, I can go the reciprocal functions. Cosecant of theta. Cosecant is the reciprocal of the sine function, so 17/8. The secant function, secant of theta, is the reciprocal of the cosine function, so I'm going to call it negative 17/15. And cotangent of theta, the reciprocal of tangent, so negative 15/8. And so that's how I would use a point on the terminal ray to calculate the values of the trig functions. And the truth is, I don't even really need to know what the angle theta is. I just need to know the location of the terminal ray, whether it is maybe this positive angle theta, whether it is this negative angle alpha. It wouldn't really matter because the value of x doesn't change, the value of y doesn't change, the value of r doesn't change. So the trig function outputs would be the same. So that's our first example. Second example follows similarly with slightly different information given. An angle theta is in standard position, terminal ray in quadrant 3, on the line y equals x. Find the values of the trig functions. Well, to do this, I need a point. So this might be a good place to start with a picture. So I'll draw my coordinate plane. I will draw an initial ray and a terminal ray in the third quadrant. I don't know what angle it is. Like the last problem, I don't really need to know. But I do know that that terminal ray coincides with the angle, with the line y equals 3x. So that's the line with a slope of 3 and a y-intercept of 0. So that would be something like this line right here. And to solve this problem, all I really need is any point along the terminal ray. It doesn't really matter. So I can just, that's not a great color there. It's not showing up very well. I just need some point along the terminal ray. And what I'm going to do is I'm going to use the fact that the line has a slope of 3 just to count backwards and say that I could go, if I went over 1 and down 3, that would, if I went from between there and the origin, rise of 3, run of 1, kind of old school there, that would give me that point on the terminal ray. So that's the point -1, comma, -3. Excuse me. Now I could have done it several times, but any point on the line would have been fine. And so now I know that for me, I'm going to choose x equals -1, y equals -3. I have to calculate my r. And I can use the same technique to calculate r that I did before. X squared plus y squared equals r squared, because I'm going to be looking at a larger circle that the terminal ray has intersected. So -1 squared plus -3 squared equals r squared. So that's 1 plus 9 equals r squared. So r is going to be the square root of 10. And that's okay. We'll just leave it as the square root of 10, and we'll deal with that and rationalize as is appropriate. So let's see. R equals the square root of 10. So I now have the 3 values that I need to calculate my trig function. So x is -1, y is -3, r is the square root of 10. So I'm just going to scroll there a little bit. Sine of theta, y over r, so it'd be -3 over the square root of 10. And just a quick rationalize there, -3 root 10 over 10. Cosine of theta would be -1 over the square root of 10. A quick rationalize, -10 over negative square root of 10 over 10. And tangent of theta would be y over r, which actually just simplifies down nicely to a 3. Then I can use that for the reciprocals. Cosecant of theta is going to be root 10 over -3. We're negative there. Secant of theta be negative root 10. And cotangent of theta is going to be positive 1/3. Just taking the reciprocals there. So there's a couple of quick examples on using lines and points to get us going. I'll have a follow-up with a couple of more examples just so you can break it down and see what you need to see. So you can watch for the follow-up video as well. Thank you.